this 10 years with a presentation entitled The End of Agile. Or at least the end of Agile as we know it so far. I'm on your way there. Is this game long enough for me to do something else? Okay, let me do something so that I'm not too much in your way. How about that? Then, I'm a prof at UBC. That's my retirement job. If you remember the Peter principle, I've probably achieved my ultimate level of competence there, or incompetence. I just teach undergrads and a few grad students occasionally, like this tall guy there. So, it's been about 15 years that we've heard the word agile hammered to us again and again. So, when they asked me to make a speech here, I said, well, I've already said everything I had to say about the bloody agile thing. But okay, let's look at a few things. The road traveled so far. Where do we stand today? What has changed? And where do we go from here? Actually, I'm very often asked these kind of questions. Okay, so this agile stuff, what's next? Is DevOps the next thing? Is SOA the next thing? Is the model-driven engineering the next thing? I don't know. I don't think that there is agile and then there must be a next thing. How do we scale agile? Well, some people will speak about this during this conference. This guy also has dropped his nose into this thing. How do I do the thing that seems to work very well when we are 12 around the table, when to a project where we have 120 people around quite a few tables and then a few time zones? How do we transpose this agile stuff to other domains than just software development? Because there seems to be some good ideas there, and we should be able to apply them somewhere else. And then there is the introspection and self-flagellation. Are we agile enough? Do we do enough daily stand-up meeting to be qualified as agile? When some new fancy word arrives, is this an agile method? Is there a good criteria to distinguish something that is agile versus something that is non-agile? How do I make my organization more agile? And this feeds a lot of us consultants, well, come over here and spread a little bit of agility on the top of my software development. And a more recent one, do you teach agile at UBC? I'm not sure that this is something that you actually teach in a classroom. So, I've been in software development for many years. I punched my first card in September 1970, I think. Punch cards, quite a concept. It was really one line at a time. So we've done a lot of things about software engineering, and those were the main topics around 1990. Around 2011, we are basically in the same place, except we've successfully placed the adjective agile in front of every single one of them. A lot of people can be credited. We started with just agile processes or agile methods, and then Scott Ambler, had agile database, and so. Honestly, I'm not sure there is any battle to have with some mythical, piñata called the waterfall. We've been beating against the waterfall for a long time, and we can just declare the game over. So this war that a lot of agilistas feel like they're fighting, sometimes we've lost track of what was the war about. So I'd like to reflect on that a little bit. And I'll be citing a lot of people that I've met over the last 20 years. Very smart Aussie called Rob Townsend, or is he New Zealander? I forgot. Somewhere down there. He looked at IT project and he showed that there were distinct stage and some kind of a pendulum sort of going one way and the other. So the dark age is actually when I started, when I punched my first cards. And then tokenism, and then payback, the pendulum swinging back, and then partnership. So dark age, from the mid-60s to the late 70s, projects were really done in special rooms with special equipment, using big computers that were on elevated floors with air conditioning, blowing cold air into massive amount of electronics. And people in those days, they really held the fort there. Trust us, we know what we're doing. So there was very, very little oversight over what was happening in those days. Then a series of events happened. Probably the most striking one for us was the lawsuit between the US government and IBM that led to actually the birth of the software industry. Software was debundled from hardware and was not just delivered for free. When you bought a computers in the 70s, all the software came for free, bundled with the hardware that was the expensive piece. So a lot of the original system, which had been written for a large part of them in antiquated languages like Fortran and COBOL, and a lot of stuff in assembly code, so very, very specific to a given machine, started to be redeveloped. There was a lot of deregulation, lots of competition started to happen at the software level, not just at the selling big hardware pieces. And we saw the appearance of more disciplined approaches. At the time, I was working with the telecommunication company called Alcatel. The telecommunication companies, I don't know so much about North America because I was living in Europe at the time. Ericsson, Siemens, who was in the telecommunication, Thomson, the French company, Alcatel. Those were really the pioneers in developing software engineering methods. Some large companies started to realize that developing software was costly, and they wanted more control over cost and more control over quality. Outsourcing curiously started also very modestly in this time frame, but the techies had the lead. And I know I was part of it at the time, at Alcatel. And then in the 90s, the pendulum swung back to the business side. People started to be very interested in return on investment. Yes, we're spending millions of dollars buying new computers every 2 years. Why are they getting so obsolete so fast? And redeveloping software using yet another programming language on yet another operating system every 2 years too. So large organizations started to be puzzled. We've invested a lot of time and effort and money in developing stuff, and then 2 years later, you software guys tell us, oh, just throw the whole thing away. We need to re-implement it using this brand new technology that just appeared. Business re-engineering started to be a big buzzword. And outsourcing started to be used as a leverage to sort of say, well, if you don't get your act together, you here in London, Paris, Stockholm, I was living in Stockholm at the time, we're going to outsource the software to places where things are a little bit cheaper. What happened very actively in that period was what I call the destruction of trust. And this was the beginning of the rise of a relatively bureaucratic, paperwork-driven approach to managing software projects. So arrived the next century, and from 2000 on, pendulum started to swing back in the other direction again. With a more open negotiation. Let's sit down around the table and see what can be done within certain budget and time, and how can we improve the delivery of things rather than building relatively rigid contract-like approach to software development. Although governments and agencies and and large organizations continue for a long, long time to have a very rigid, linear view of software development. Let's pile up massive amount of requirement and let's have a contract and then let's follow the delivery of a contract, pretty much managed like you manage the construction of a road or a bridge or a tunnel or something like that. Actually, that's the reason I came to Vancouver. But the 2000s saw the appearance of the Agile and Lean approaches. So what happened up to that point was what I would call the emergence and the build-up of very prescriptive process. We thought naively at the time that we could imitate what happened in other engineering disciplines by just describing what happens in a relatively rigid way in software development, with some flexibility to adjust to context and size, but we could decompose the process of developing software in a series of steps. Each step had some very well-defined input and some well-defined output. And the concept of looking at process as a thing and judging its quality took quite a lot of roots in the 90s. The concept of the CMM, which was imposed on the US software industry by the Ministry of Defense of the United States, is an example of it. You look at your process, and there are a certain number of attributes to that process, and the process is described as a thing. There was a few other things that happened at the time. There was a very big push for quality under the umbrella of all the ISO 9000 standards, which when you look at them, you had a hard time applying to software. So a special version of ISO 9000 was issued, called 9000-3, which rephrased ISO 9000 in terms that could be vaguely understandable by software developers. The software process improvement movement, spin networks, something like that started to appear in various places. And coming from a totally different direction, organizations who had embarked on a very big improvement in developing quality products wanted also the software people to be involved in that. So Six Sigma, what does that mean? Do we have some tolerance on each line of code? So there was a lot of joke about how do you apply Six Sigma, a manufacturing concept, to software. But people found ways to sort of, join the party there and contribute to the overall quality of a product. A bad thing happened at the time. The IEEE was developing a series of software engineering standards, and there was a gap there. There was nothing that really filled the area of project management, software project management. So they just decided to adopt the PMBOK as the IEEE standard for software project management, which was, in my opinion, a very big mistake because it made a management process that was developed mostly by civil engineers, including one that lives in Vancouver. What's his name? Max Weidemann. It made this process the de facto framework for describing the software management process. So around 2000, we were in a sort of difficult situation, and it was time for the pendulum to move back. A lot of people started to be relatively disgusted with the way projects in software were being driven, initiated, managed, with trying to follow some written process. And I was part of the problem too, having developed the rational unified process here in Vancouver. So there was some sorting out that happened. A lot of people said, well, I don't need this crap. I can go with my buddies and develop software in a much more flexible fashion. One person who described it in some ways is Jim Collins in Good to Great. Most companies build their bureaucratic rules to manage the small percentage of wrong people on the bus. So yes, we need to keep these people, well aligned, and we need to check every week that they follow the plan, which in turn drives away the right people on the bus, which then increases the need for more bureaucracy to compensate for incompetence and lack of discipline, which then further drives the right people away, and so forth. So in this whole process from the mid-80s to about 2000, something was forgotten. The real nature of software. And I was looking at the various presentations I've made to Agile Vancouver of the last 10 years, and this was one of the first one in year 2, I think. Software is not like other things that we do in engineering. It's not like roads and buildings and machines and things like that. The first thing is that unlike our colleagues in other engineering disciplines, we do not rely on some well-understood immutable laws of physics. There's actually very few laws of software that would represent the equivalence of the laws of physics that would allow us to reason about software before we actually deploy it. This has been the dream of computer scientists for quite a long time. Yes, we could have formal method and formal definition and prove the software correct before it even touches the computer. And yeah, it's been a dream for 40 years, and I don't think I'll see it in my lifetime. So we cannot validate software based on its blueprints, like we do in other engineering disciplines. We have just to build it and try it. And the second thing is software. It's extremely modifiable. And we all know that. We cannot pretend that we're going to build that thing and then that's it. It will be delivered on D-Day and it's immutable. You do that when you deliver a bridge. There's very little changes that you can do on a bridge across the Fraser Valley. You can put a little bit more Teflon on the cable so that the ice doesn't fall on the windscreen. But that's about it, little touch-up. Software, we all know, we can change it dramatically or just a little bit or evolve it. And so it's extremely modifiable. And both we software developers and the end users or customers, if they're not the same, we know that and we want to exploit that flexibility. So the mentality that we had in the mid-90s where, okay, I want to freeze the requirement and in 2 years I'll deliver something that is 97% close to this requirement, that doesn't work too well. And then there's a few other things. There's no manufacturing cost. It's all development cost. It's all R&D. Once we have the executable, the cost of reproducing it is null today. Well, I still remember when we were shipping magnetic tapes, big things like that. And yeah, you would have to buy a tape and write the tape and put it in a box and give it to FedEx or whoever was FedEx before FedEx existed. I remember driving tapes around Europe and having to explain to custom officers, it was before the borders dropped, that yeah, no, this has absolutely no value, it's just about 100 French francs, and they said there must be something on the tape, it has a value. Well, we don't know. Well, those days are gone. I can download the software from anywhere in a matter of minutes. So in some industry, it's not that easy. When the software is really embedded in some device that's not connected to the net. Then there is this thing that we are suffering called technology churn. We tend to develop new technologies. Last century it was new programming languages and design method, but now it's other things, it's platform and stacks, and the LAMP stack has been replaced by the Lean stack, which looks a bit nasty to me, but a pretty successful thing. So this technology churn is also having a big effect on the way we drive our industry. When I described to my grandfather, who was a civil engineer, the finite element method program that I was developing as a student, he told me, oh yeah, we were doing the same with computers in 1922, except the computer was a bunch of people in a room passing little piece of paper and having adding and multiplying machines. But yes, fundamentally, the technology hasn't evolved that much in other disciplines. So the consequence of this very different nature of software, and we started to really realize it around the birth of Agile. It's a creative activity, it's not a manufacturing activity, it's not a construction activity, it's not an administrative activity. Most of what is important in software is that creative aspect. It's a knowledge-intensive activity. And trying to sort of say, well, let's have some inputs and that big machine made of little processors and the right thing will pop out of it, and we can populate that machine with little machines called humans that are more or less morons and just follow the process. And the concept of having a software factory that didn't pan out too well. It's also, compared to other engineering endeavors, much more uncertain and full of risk. And then there's this high pace, high pressure from the surrounding organizations. So when we try to cast software development or software engineering, whichever you want to call it, in the framework that came from manufacturing or civil engineering, a lot of things fall apart. And that's where the traditional project management approaches have failed. So, 2001 came the Agile Manifesto, and you've probably seen it 275 times, so I will spare you the manifesto and won't read it. Okay, so here I could insert, a whole speech about how great this was, what kind of fantastic progress we've made, all the good practices or best practices, if you're really convinced that there will never be anything better, have appeared. Yes, it has done quite some good to our industry in general, and even sort of transpired a little bit around. I will skip my personal rants about all the dogmas and schools and little battles and splits and labels and finger pointing and your Agile is not as agile as my Agile and you're not certified. Are you still certified for whatever you're preaching? I don't know. So in the Agile microcosm, suddenly there were all these little battles and churches and sects, and this was sort of amusing to a point. This is mostly because this was a movement that was pushed by a lot of talented and opinionated individuals who had to make a living and create little groups and compete against each other. It was funny to see.
Kind of thinking, okay, I'm going to do a half-hour panel and then just hang out and listen to everybody, and suddenly, oh, by the way, Steve, could you be the MC? Right. So I'm going to be doing something that, anyone here ever been down to, this part of music in Tennessee? Memphis, Tennessee. Anyone been down there? Gone down Main Street? There's all these great bars. It's really awesome. If you haven't been there, if you love music, it's not just country music. You go to Tennessee, and you start walking down Main. Main Street, and going on bars. You can go into a bar, grab a drink. If you don't like the singer, take your drink, walk to the next bar. Like I said, if you really love music, it's an awesome place. Anyways, literally, I walked into one bar. There's a girl with her band, and she's singing the lyrics off of her iPhone like this. And it's like, okay, don't give up the day job. So I said I got sort of press gang into this. My name is Steve Adolf, and I will be on one of the founders panels. But this whole conference started 10 years ago when Philippe and I were sort of sitting in a bar, and he says, let's have a conference. And I'm going, what? Are you crazy? And we've been having much ado about Agile for 10 years. It's been one of the great success stories about Agile Vancouver. Philippe is our keynote speaker. I believe he's still trying to find parking, which means in Vancouver that could be sometime next year. And I just want to go over what the agenda is for today. Theoretically, at 8:30, Philippe's going to be here. It is now 10 minutes late. Okay, this is Vancouver. So Philippe has got a keynote from 8:30 to 9:45. We have a 15-minute break for coffee, and then we have the co-founders panel, which features myself, Philippe. Is Jeff Houston here?
No, he's not going to make it.
Not going to make it. Eugene, I believe Eugene Nisker is on it,
Yeah.
and is our good. Oh my God, I must be starting something. Jazz.
But he sent a video.
Jazz sent a video. So Jazz Madhur, who's in Europe these days, I believe he's in Belgium or London.
You have to ask Eugene.
Yeah.
Sorry.
So Jazz will be sending us a video. There is the annual general meeting, which lasts about 5 minutes. After that, the purpose of the annual general meeting is to keep Agile Vancouver basically legal as a not-for-profit society. There has to be an annual general meeting, and effectively
It'll take all of 3 minutes.
it'll take all of 3 minutes just to basically have a vote. Here's the directors. Anyone want to be a director? So at 11:15, another break, and then we split into two tracks. And here's going to be these are both really great, and this is annoying me that they're both on parallel tracks because I want to sit on them both of them. So two good colleagues of mine, Jennifer Fawcett from Scaled Agile Incorporated. Is she in this room? There, Jennifer?
Jennifer's in this room.
So Jennifer Fawcett will be here with 9 immutable principles for implementing lean agile development at enterprise scale. I've worked with Jennifer. It'll be a truly great presentation. And then the problem is, there's another really good colleague of mine, who's a great friend of mine, is Mark Lyons. Mark, where are you here? Mark?
We were collaborating, thinking how we could make it 1 o'clock.
See, this is about self-organization and collaboration. So disciplined agile delivery, the foundation for scaling agile. So like I said, this is always a drag with multi-track conferences. These are 2 really good presentations. Lunch is at 12:30, after which we have Adrian Moyse and James Shore from 1:30 to 2:45, using speed and agility to launch winning products faster with less risk. And James Shore, leading best fit agile. And a break, 3 o'clock. This is a good one. How Just Eat leverage Amazon Web Services. So this is Brian Packwood, so this case study from Amazon. And where is my minimal viable product? Adina Karjaj and Jeff Morgan. And then at the end of the day, there's a panel. So I see Philippe has arrived. I need a few minutes to get set up. You're all good to go? So before I introduce Philippe, any questions about the day? Washrooms are down at the end of the hallway. And we are being catered.
And feedback baskets at the end of each session.
Good pardon?
Feedback baskets.
Yes, there's a feedback baskets at the end of each session. You're still doing the coin thing?
Yep.
Okay.
There's red, yellow, and green baskets depending on how you feel about the session.
All right. And do we know what the Wi-Fi password is by any chance?
There isn't.
There isn't a Wi-Fi password.
We can't afford the Wi-Fi.
Can't afford the Wi-Fi, so you're either tethering by your phone, or let's do something unique. Let's actually focus on the presentation and talk to your colleagues. So as we would like to say, without much further ado, I'm going to introduce my colleague.
Without actually seeing it. Actually, Barry Boehm, my buddy from University of Southern California, who went from General Dynamics to a position as a prof like I did, he had this icky-wizzy acronym. I'll know it when I see it. Show me something, and then I'll tell you, oh, no, how about we have a dialog box that does this. Oh, I don't like this. Oh, that gives me an idea. Maybe the software, show it to me, and I know what I want. My former teammate in Leffingwell at Rational Software said it in a different ways. If we think that we can nail down all the requirements at the beginning, we're probably wrong. Oh, I have two from Martik again. Customers do not know what is possible. Most have no idea about the enabling technologies involved. So we have to expose also what kind of technologies we may want to bring in order to generate ideas about what the thing could do. Steve Jobs, this I've seen many times. You can just ask customer what they want and try to give that to them. By the time you get it built, they'll want something new. A great UI UX specialist, Jacob Nielsen, the author of the famous 10 heuristics that are very, very prevalent in this industry. The critical failing of user interviews is that you're asking people to either remember past use or speculate on future use of a system. Okay, I couldn't resist. Lewis Carroll and the Red Queen. It takes all the running you can do to keep in the same place. If you want to get somewhere else, you must run at least twice as fast as that. Okay, so a big problem that we have, and we have the easy scapegoat, we the software developers will just blame it on the analyst, the business analyst or the customer. Oh, they don't know what they want, or they didn't do a good job. So you get the software that you wanted, but so we have this escape valve. We can blame it on somebody else. So customers do not know what they want until you can show it to them. And let's not say this is impossible, or let's not put that on the knees of the analyst or the requirement engineer. Let's just look at it as some kind of an experimentation system where we can actually put something and show them something very, very quickly. So increasing speed gives you the short cycle time that allows fast experimentation. And now we can do that. We have the technology to put in front of the user new things very, very rapidly. I'm speaking about hours or maybe minutes. When we can do something which is not always obvious, we can do things like A/B testing and look at, does that make a difference? If I expose 50 of my users to something different, does that make a difference? Can I measure the difference and then decide whether or not I should continue in that path? Now, in order to do that, and to do that very rapidly, we need to have a relatively strong focus on design and software architecture, which is another of my pet peeves. I've seen in the whole Agile movement, people sort of assembling things very rapidly without a very explicit focus on architecture, and an architecture that can evolve. So when people tell me, oh, DevOps, it's the new Agile, well, maybe in the title of conferences, DevOps is the new Agile. It takes a lot of people to that new audience. But this is just an example of doing what I've said. It's a way to shorten the cycle. Shorten the cycle by changing the organization and the interface between people and the role of people and using different tools and technologies, but it's just increasing the speed in order to run faster experimentation. So what are the practices that will develop in, not to replace Agile, not to create a new movement with another fancy adjective, but the practices that we'll need to bring are mostly about reduction of cycle time and continuous delivery, which some organizations are doing pretty well, some are just trying, some do not need it, so they shouldn't try to push themselves too hard. are focused on an evolving architecture, that is having a design in the noble sense of the word design with a capital D, where we can see a path for evolution, an emphasis on metrics, objective metrics to support decision, so that we can make choices relatively rapidly, not just on gut feeling or opinions or cognitive biases or whatever, but on objective facts. And exploiting the ecosystem, exploiting other components and systems that exist in your vicinity to develop things more rapidly. Now, not all environments can do that. In some cases, it's not really appropriate. So looking at your specific context remains something very important. So the need for speed is also driven by just business consideration. If you have a company that dedicates 10% of its revenue to research and development, therefore will spend $100 million to develop a new product which has a value of $1 billion, and the development cycle is 12 months. Let's say something in the automotive industry, speak about BMW or somebody like that. So our big focus for us in software over the last 20 years was improve efficiency. Okay, let's try to be more efficient at developing software. Software process improvement network and all those things were all trying to shave a few percentage there. So if we improve efficiency of development by 10%, basically that saves us $10 million in development. But if we reduce the development cycle by 10%, that is, we are 1.2 months earlier to market, then we can actually add some revenue to the top line. So our search for little increments in efficiency in the way we develop software would not pay as much as anything that we do that allows us to deliver just 10% earlier. Maybe a little bit contrived example. So how can we do that? Well, just manage the thing as a systematic experiment. We're going to use every single iteration as one more step in an experiment, and we know what we want to get out of that experiment. And we put in place ways to collect metrics and collect data and massive amount of data about that experiment so that we can drive the next iteration. So what we've seen is a decreased cost in collecting and exploiting a lot of data about how our users are using the system. We may need to instrument the system in some ways, and we can exploit things not just in our own little narrow niche, but in a wider ecosystem, and use open source software. In retrospect, somebody who had this intuition was one of our early speakers at Agile Vancouver, Eric Ries. I don't know if you remember. And he had this notion that we go from idea to code to data, and that we need to measure. We need to measure, but not just at the end when the product is done. We need to measure at every step so that we can drive the next step, not based on what's in our backlog, but also what we've learned about the use of the system. There are, however, dark clouds ahead, I think. And we need to look at friction that prevents speed. My former colleague, Grady Booch, said it eloquently. There's still much friction in the process of crafting complex software. The goal of creating quality software in a repeatable and sustainable manner remains elusive to many organizations, especially those who are driven to develop in internet time. We learn sometimes from various war books, Chinese one and German ones. So Clausewitz wrote, friction is the one concept that separates real war from a mere paper exercise. So where does that friction come from that we should address? There is technical debt. I'm not speaking about little imperfection called smell. I'm speaking about more significant technical debt. And there is social debt. Both contribute to that friction that reduce our velocity, our speed, lengthen our cycle time. And it also has, some nasty consequences of increasing the number of defects and increasing random delays. So technical debt is a strange concept. It's a metaphor, an analogy to financial debt, but it's an analogy that you shouldn't push too far. We can walk away easily from technical debt. At the big Agile conference, one of the last one we were together, half of the audience was just consultant trying to show off better than the other half of the people, and only half of the audience was just there naively willing to learn something about Agile. So I wrote a long rant on my blog at the 10th anniversary of the manifesto called the elephant in the Agile room, which made me quite a few enemies, as I was the enemy of Agile. So what do we do now? I will not list all the successes and advances and advantages of Agile, because I feel that usually now in this kind of meeting I'm preaching to the convinced. So I will look a little bit how our knowledge evolves. So I'll wear my prof cap for 5 minutes. Knowledge. What is knowledge? Knowledge is validated belief. Things that we know, and we know that it works, and it has been validated in some ways. Sometimes in a very small circle, sometimes in a very, very big circle, sometimes it's some universal knowledge that is true for a lot of people. So knowledge, more specifically in our field, it's not like software engineering or software development. It's not a natural science. It's not, I need a bigger microscope to go deeper into the structure of the atom or the brain of the software consultant. So it's an artificial science, as Herbert Simon calls it. So I'll distinguish different aspects of knowledge. There's tacit knowledge, and there's explicit knowledge. Now, this is not binary. There's a continuum there. Tacit knowledge is stuff that is in your head. It's in between your ears, things that you know or know how to do or know how to recognize. And there is explicit knowledge. At one extreme, it's written in books, so it's accessible by Google on the web. And there's stuff in between, stuff that is on the PowerPoint slide that I collected at that conference, the memo that we shared, little things that we've put on the company or the project wiki. So there's tacit knowledge versus explicit knowledge. There's also another dimension. There's generic knowledge versus specific knowledge. There's knowledge that can apply to one specific team or project or system or technology, and there's knowledge that is much more widely applicable. And again, this is not just a binary thing. There's a continuum there. So if we look at tacit versus explicit, some people have looked into that and how we go from tacit knowledge to explicit knowledge in a sort of circle or spiral, as they describe it. So there's two very interesting Japanese researchers, Hirodata Takeuchi and Ikujiro Nonaka, who looked at this and described it in what they call the Seki model. Seki for socialization. I'm there, I'm chatting with Steve, and we exchange things, and we disagree, and then we agree, and we go to the whiteboard, and we share things. And his life experience is slightly different than mine, and then so there's some kind of socialization of aspect. And then out of that, we capture something. So part of this tacit knowledge becomes explicit. We capture it in some ways. And then this explicit knowledge is distributed to other people. So Susan grabs it, moves to another project, and then say, oh yeah, there's that stuff there that we did in this other project, now shares part of the explicit things, and out of that you pick up new tacit knowledge that you recombine in other forms, in another settings, to create new knowledge that is now tacit at the beginning, but gradually, if it's valuable, will become more and more explicit. Nonaka and Takeuchi should be well known to all of you because they're much better known for being the originator of Scrum. Sutherland and Schwaber actually got their inspiration for Scrum in a very famous Harvard Business Review paper in 1995, I think it was, called the New Development Game. So Nonaka and Takeuchi are really at the root of one of the major methods in software engineering, the Agile version. Okay. Then there is generic versus specific. Specific is what we know about a specific instance, about a project, about a team, about a process, about a technology. And generic is things that we can generalize. And there's also some movement between the two. Actually, one of my pet peeve against the Agile movement is the tendency of Agilistas to quickly generalize out of a sample of one. I've done this. I was very successful. Therefore, all software projects should do this too. Yeah. And we've seen a lot of that. Putting things completely out of context and generalizing practices that may have worked very well in your context, but are very, very hard to transpose to a wider context. So let's look at both aspects. I can do quadrant 2, like marketing people. So we have this generic to specific axis and the tacit versus explicit axis. So having quadrants. So I vaguely sketch, the movement between tacit and explicit, where things that are just words that we speak becomes captured on whiteboards and then put into notes and then into company manuals and then end up in textbook in universities and Wikipedia pages. But there is also a process by which we go from specific to generic. So, and that's where people like the consultants have played their role. Having poked my nose into many different projects around the world in the area of defense and aviation, I noticed some patterns. I noticed that some things systematically do not work and some things systematically work. And out of that, you can create and make things that are much more generic and therefore applicable to a wider range of projects. So abstracting from multiple instances, sorting out the good and the bad, allows you to develop some more generic knowledge, which you can then reuse in other projects. And at Rational Software, where I worked for almost 18 years, we were actually organized among the consultants to do this in a very systematic fashion. We would gather twice a year and tell each other war stories from the project that we were involved with, and out of that, some generic knowledge would be extracted, and some of us would be tasked to actually make it explicit by writing it down. Many of the books that Grady Booch wrote were the result of that process. The Rational Unified Process itself was the result of this process of trying to systematically harvest things out of instances expressed in different languages with different terminology and make it more generic. And then there are things like maturation. The explicit generic stuff can be exposed to more people and get some feedback and can mature over time. And the specific things can also be refined over time. So if we apply this to our agile world, you know, the task specific. I work on a project, I do stuff, and it works. Right? I improvise something, I have no clue why I'm doing it, but we have a little bit of a discussion, and we do stuff. And then, because it works, we want to do more of it. So we're going to make it explicit. So I'm going from the yellow box to the blue box. We describe stuff that works for us. And then when stuff that works for us seems to work for you too, and also for you, maybe there's a need to generalize it and abstract it. So we write blogs and books about stuff that works. But some people are just, you know, like consultants, they're on the red box. They just observe stuff that works, but don't actually spend the time to describe it in an explicit fashion. So, hey, we pair, and it works, and I write code sitting next to you, and actually, we're pretty happy about the result. Okay, maybe we should do that in a more systematic fashion. You two are going to pair tomorrow, and you two are going to pair tomorrow, and we'll see if that works, and we make it a rule in our team. All the code is written in pair. So we've made things now explicit as a rule in this project. And then some consultant may notice, you know, going there and visiting this, that actually lots of people seems to be pairing, and it works. So maybe in my next project, I will say, you know what, you should try writing code in pairs. And then finally, Ken Beck or Ron Jeffries say, we should, you know, express that as one important practices in our XP process. So that's the green stuff. So different people play different roles. The practitioner just does stuff that works for him or his immediate surroundings. The technical lead would try to make sure that things that work, we're doing more of it. The consultant smells around and, you know, replicate things from one project to another, and the guru writes books about it and gets rich and travels the world. So we have, you know, exchange of knowledge and this movement between tacit and explicit, and the movement between specific and generic. And it doesn't stop there. Now, there may be explicit generic stuff that is in books, and you have to learn them and still have a pulse at the end so that you're a Scrum Master. And then maybe it doesn't work. Maybe something different happens. So we use now this, what we think is established practice that should be done by every single software project, and we can challenge it because we try something and it doesn't work, and we can create new knowledge by challenging even the explicit generic stuff. So Agile is not an end state. It's not something that exists out there and we're getting closer and closer to the truth. Agile is something that is completely manufactured and will change continuously because we create new knowledge. And why do we need to create new knowledge? Because the context is changing. We're in 2015, and it's not exactly the same world as in 2000 when Ken Beck wrote Embrace Change. So what is at the core of Agile? Is there something that sort of unifies all those things? Oh yeah, it's the manifesto. Well, maybe not. The manifesto and the principles, they were, in my opinion, a bit hastily written, and they do not stand really as principles. They're mantras, they're wishes, but they're not really fundamental principles. So when we look at what is agility, there were two people who gave me some very good answer. One is Jim Highsmith, and the other one is this guy over here. Because we scratch our head for many days or even years about what the heck is agility. How can we, specify and qualify agility? Okay, that's the best we could come up with at the time. There's probably better ways to describe it, but I think it encapsulates, if I had to do it in one sentence, it encapsulates it very well. So there are two things in contrast with the state pre-Agile manifesto. There are two things that are very important. The first one is the human aspect. Most of the processes, almost the totality of the processes that were developed before 2000 didn't pay much attention to the human, social, psychological, social dynamic aspect. They were very, very focused on artifact, the design, the diagrams in UML, the test case, the test, the compiler, the tools, the configuration management system. All those things were the important number one citizen. We understood vaguely that some human beings were doing, some of the steps there, but it was not the important stuff. The other thing which existed before but was not emphasized in a large chunk of our organization because of the mistakes we had made in the 80s and 90s in embracing very linear waterfall management processes was this concept of iteration. So for me, the key principles of agility are not the ones that are attached in the back of the manifesto. They're feedback loops. Version 1 had a very, very nice diagram with all these feedback loops at different level of granularity from the minute I'm sitting next to my the other side of my pair to the daily stand-up meeting, which is at the day level, to the retrospective and things like that. It's just a pity that this diagram was too pale, and the few copies that I found did not show up very well. So feedback loop, building these feedback loops is, one important principle in many of the practices that we've developed pre-Agile manifesto and started to roll out very actively post-Agile manifesto. And they do not reflect just on the process, they reflect on the business, on the requirements, on the risk, on the people themselves, on the technology that we use. So we need to make sure that we continuously build and exploit these feedback loops. And some of them are very explicit in the practices that you're familiar with. The other thing is a focus which didn't exist before 1998, roughly, in communication and collaboration. How do people communicate? Face-to-face communication as opposed to relying solely on artifacts that are under version control. And collaboration, how do we work together? Pairing is an example of having both tight feedback loop. I'm getting some immediate feedback on what I'm doing by somebody who has a different perspective and looks at the same screen but has a different mental process behind it. And collaboration, we are collaborating, we are working together. An important thing, and I noticed that, is we need practices that rebuild trust. A lot of the processes that were described up to the mid-90s assumed that everybody was a bad person and would do bad things. And there was this active destruction of trust in IT departments relative to the rest of the organization, but also inside the IT department or software development organization. So communication and collaboration and putting the individual there and taking into account how people think, how they think differently, how they reason, how they make decisions, how they accumulate knowledge, how they make mistakes, how they have cognitive biases, another presentation I made a few years ago at Agile Vancouver. cognitive biases, errors in judgment that we make because the way our brain works. All those things are sort of folded in some of the practices. But sometimes people look at the practice at the surface and do not understand, the underlying principles that it tries to draw from. So Steve did a lot of work on software development as a social endeavor, where people are not, taking some input artifact and transforming them into some other output artifact to hand over to somebody else, but where we are constantly, reconciling perspective. It's a constant tension to get to some point by reconciling perspective. I will not go into the details of this relatively complicated diagram, which is the sum of several years of reflection. Another thing that we have to realize is that the context has changed. Yes, we can continue to try to do things as if we were, trying to kill the waterfall in 2001. But we are in 2015, and in our context, in software development, things have changed too. Toto, I've got a feeling we're not in Kansas anymore. So, what has changed? I don't know, the cloud changes things. Mobile devices were not that prevalent at the time of the Agile Manifesto. The Internet of Things, maybe it's something that you haven't even heard of, but this is going to dramatically change quite a few things for some of us. Big data, analytics, machine learning, being able to process lots of data, even inconsistent data, and draw some conclusion out of it to help decision support, software ecosystems, little things that work together with some compatibility around some major players. So there's some ecosystem around the automotive industry and some ecosystem around eBay and around Amazon and around Intuit and open source software, which was just burgeoning in 2000. People say, yeah, okay, some academics or some little project, they can use this open source stuff. The real software is the proprietary one that we've written ourselves. Well, this is changing dramatically too. So in 2000, our industry was trying to make some progress in order to have projects succeed. Actually being able to deliver something. To be able to deliver something that was maybe not what we had envisaged on day one when we wrote the first line in the requirement, but deliver something that was of value to the business, the end user, and so on. But I would say now that in 2015, the need has changed and we have a need for speed. A lot of people have spoken about speed. If I had asked my customers what they wanted, they have said a faster horse. Marty Kagan is a guy who has a company in the Silicon Valley called Silicon Valley Product Group. Customers do not know what they want. It's very hard to envision the solution you want. Try to walk away from your mortgage. Or say, you know what, I don't like the kitchen anymore, so I'm not going to pay for the kitchen anymore. Well, your bank may not like it. So what is technical debt? It's a design and construction approach that is expedient in the short term, so it helps us go through some milestone, finish delivery cycle, but it creates a technical context in which the same work will cost more to do later than it would cost to do now. So there's different forms of technical debts. If you Google technical debt, you find 6,000 blog entries because every single software guru has written one, sometimes citing a few others like Martin Fowler or Steve McConnell. You know Steve McConnell, Code Complete, software project manager, survival guy. He's in Seattle, his company is called Constructs. So technical debt, there's many aspects to technical debt. a lot of people are focused on small imperfection, code smells, badly named variables, useless loops, method that spread over 2 pages, code clones that may lead later on to mistakes when you don't find all the clones and update only n-1. There are some fuzzy boundaries. A lot of people tend to put defects as a kind of technical debt. Well, let's face it. If something is a defect that affects, the end user and is visible by the end user, calling it technical debt doesn't make it nobler. So a defect is a defect. Fix it. Don't call it technical debt. Technical debt actually is just strangely done. It's not wrong. It doesn't have some immediate visible consequence on the functionality of the system. At the other extreme, new features, additional functionality, that's not technical debt. It's just stuff you haven't done yet. I can drool in front of the BMW shop as long as I don't enter the shop and leave with a car, I'm not in debt. Okay, it's just stuff we haven't done. So technical debt is really stuff that is invisible. Well, it's visible to us, software developer, because we've done it. We've done it for some reason, sometimes ignorance, reckless debt, as Martin Fowler, who was our invitee some 5 years ago, or deliberate, careful debt. Okay, let's do that now, because we have some milestone and we'll fix it next week or next month. And then we don't, and then we pile up recurring interest. The debt that I'm speaking about is more at the level of the structure or the architecture of the system. Having organized a system in a way or picked some technologies in a way that lead us to having a very, very difficult time evolving the system. So we are now reached the point where we produce software that we cannot afford as an industry to maintain and evolve. There is more software that is being produced, and it's going to consume an increasing amount of the workforce in software development to just maintain the good system that we want, just to maintain them and evolve them. Now, we've used some escape valve over the last 2 or 3 years to absorb this by shoving a lot of the maintenance to remote countries. Brazil, Latvia, Thailand, and so on. But the cost associated with evolving and maintaining existing software systems is now higher than the cost of new development. So technical debt is really an important topic that we cannot just say, oh, it's an interesting little metaphor, and let's move on, and we'll just put a few items in our backlog, and we'll twist the arm of the CEO or the project manager to let us have a few iterations to catch up on technical debt. It's a more acute problem than this. So what is needed is process and tools, and we probably need to include the people in there to identify and measure and prioritize and repay or just monitor technical debt. And again, I'm not speaking about little imperfection that can be detected by any good static analyzer. You know, you can run Sonar or J or something like that. We probably also need to get some inspiration from other industries in having more standards, using more open source solutions, which are still not really embraced by the whole part of industry. In some ways, some of the software ecosystem create some de facto standards. And we probably need also to do the job at the level where I am now by explaining to people who study computer science or software engineering that it's not all about creating new software. We should have exercise and project where we take a large body of code and just do some evolution on it. and analyze the technical debt that is embedded in this large body of software. There's too much focus on creating new things ex nihilo because that's the fun of it in year 1 and 2. But maybe in year 3 and 4 or later we need to have more focus on software evolution and maintenance. So Agile was just a stage in the journey. Things do not stop there. We are not going to, fossilize the movement there in a numbered set of practices or just scaling it up by adding a few others. It's not a destination. It's just part of the trajectory. There's nothing that will replace it. It will become part of the normal world of software development. It will not be replaced by something. There is not a next things to Agile. Let me use an analogy from our own world. In the 90s, there was a big debate. Should you go object-oriented or not object-oriented? Should you do object orientation with an object-oriented language? Can you use an object-oriented language such as C++ and not use the concept of class, something like that? Big debates, and now people don't even mention the word object-oriented. We're using languages that support classes and inheritance and polymorphism, and that's it. It's become part of the normal landscape. While similarly, for a lot of the younger people coming into this industry, things like having a daily stand-up meeting, a retrospective pair programming, and things like that will just be part of the normal landscape, not subject of a debate and having to have a certified Scrum Master to tell you what to do. The knowledge continuously evolves using the mechanism that we've seen earlier. But we have to realize that the context changes. Our industry and the surrounding of the industry is evolving, which creates the need for new knowledge and new practices. Some of them will supplant the practices that we've seen appearing. Some of them will complement. Some of them will be useful only in certain kind of environment. So you may want to envisage software development as some kind of a continuous experiment where you get some of the data to allow you to decide what's the next step, not just by feeding it from a business analyst and a product owner shoving more stuff into the backlog, but getting data about the actual use of the system. A big wish that I've had, having had a lot of focus during my career on software architecture, is to deal with things at higher level of abstraction. But we're not there yet at the level of using routinely model-driven architecture, model-driven engineering. It's been 2 years away for the last 12 years when I ask people like Steve Miller, for example. So in some ways, we are at a point where we see the end of Agile as some fancy magic that is used by a few people and have a secret handshake. We are far beyond the chasm, to use Moore's analogy. And that's it.